Here we'll be looking at how to find the total number of factors of a particular number. So let that number be n, capital N, and let us prime factorize it first. So the first step to find the number of factors is to prime factorize that particular number. So let the prime factorization be p raised to power a, q raised to power b, and r raised to power c. So p, q and r are the prime factors of n. Now how do we find the total number of factors possible for n? Now we see that any factor, if we choose any factor of n, we could have a power of p which could range from either 0, 1 until a. Similarly for q, we could have a power of 0, 1 till b. Any power of q we could have out of 0 from 0 to b. Similarly for r, we could have any power from 0 to c. Now if we are choosing any power from 0 to a, this means we have a plus 1 ways to choose power of p. Similarly, we have b plus 1 ways to choose power of q and r plus 1 ways to choose, that is c plus 1, in fact not r plus 1, c plus 1 ways to choose the power of r, because we could either choose 0 or 1 or anything till c. So there are c plus 1 ways to choose the power of r. So these are the total number of factors of the number n. Now note, for example, we could take any power of p. Suppose we took p square, q 1 and r we take 0, which is basically p square q. So this becomes one of the factor of capital N. Okay. Now we'll be looking at an example for the same. So let's find out the number of factors for the number 240. So the first step is to prime factorize 240. So the prime factorization is simple. We keep dividing it by prime factors. So this is 80. Now then we have 2 which goes by 40. Then again 2 which is 20. 2 which goes by 10. Again 2 which is 5. So the prime factorization of 240 is 2 raised to power 4 into 3 into 5. So basically this is 3 raised to power 1 and 5 raised to power 1. So the total number of factors for 240 would be 4 plus 1, 1 plus 1, because this power is 1, so 1 plus 1, and we have 1 plus 1 for 5, so this is 1. Now this computes to be 5 into 2 into 2, which is 20. So we have 20 factors for the number 240. Now let's try this with a perfect square. So let us take a square, let it be 49. Let's take 49, which is nothing but 7 square. Okay. So for a perfect square, we see that the number of factors in this case is 2 plus 1. So number of factors, let's call it NF, which is 3. Similarly, if we take any other perfect square, let it be 2 square into 5 square into 6 into 7 square. So 2, 5, 7 are prime numbers. For this number of factors would be 2 plus 1, 2 plus 1 and 2 plus 1. This would be 3 into 3 into 3, which is 27. Note that whenever we have a perfect square with us, the powers would be either 2, 4, 6 and so on, because we have a perfect square, so the powers have to be even. And if all the powers of all the prime numbers are even, this means that the number of factors will always have multiples which are odd. So all these will be always odd when the powers are multiple, because we are adding 1 to them and powers are even, so all these will be odd. So this means the final number of factors would also be odd. So we should remember that for perfect square, the number of factors of a perfect square is always odd.